back. This is our Comptia A Plus certification exam core 1 objectives. This is for test 220-1101. Today we are going to focus on what would be 2.3. And I'm going to be honest with you guys. I never claimed to be an expert. I am on my way to becoming a professional expert in the IT field. However, I want to let you guys know if you were struggling with this one, I feel you. Okay, I honestly do. This one was a pretty tough, and this was a bit boring and dry, and it kind of brings me back to studying physics. Okay, or at least elementary physics, in a sense. So if you felt like you were struggling with this one, go ahead and watch. If you feel like you're an expert on this one, go ahead and watch and correct me at any point in time, or if I might have said something that was inaccurate, because I did really went ahead and struggled with this one, but nonetheless, we have to talk about it because it's on the exam and we are responsible for knowing this information in order for us to be successful in our CompTIA A plus certification. So let's go ahead and get into it now. So 2.3. Okay. And before we get into it, quick pop quiz. What three wireless technologies should we definitely know by now? Okay. That's going to be Wi-Fi, that's going to be Bluetooth, and that's going to be NFC. And a lot of those technologies, the limiting factor, so to speak, or what distinguishes those technologies, the major thing is the capacity of data that it can transmit and the distance that it takes, okay, or the range that it can transmit that data. So 2.3, compare and contrast protocols for wireless networking. Let's get into it. So when it comes to Wi-Fi, guys, you need to just memorize these two frequencies here, the 2.4 gigahertz and the 5.0 gigahertz. And we're going to go ahead and talk about those. 2.4, 5.0. And I'm going to honestly try to make this as simple as possible, keeping in mind that I know they're going to be asking questions in the CompTIA A plus certification, but at the same time, I don't want to get lost into the minutia. Okay, I just want to make sure that you guys know, at the end of the day, we're not studying physics. We just want to make sure that we can set up a wireless network properly. Okay, and I want to come at it from that lens, give you guys that information that you would need. So when you're setting up your wireless network, so to speak, you keep that in mind. Okay, so 2.4 versus 5.0. Okay, 2.4 versus 5.0. I'm going to give you the stuff that you need. Okay, 1, 6, and 11. When it comes to 2.4 gigahertz, memorize these numbers: channels 1, channel 6, channel 11, because those are the non-overlapping channels. Okay, if you configure all your channels on channel 6, you're going to more than likely have some interference and congestion, which is not good. Okay. You want to almost have like this honeycomb effect. But when it comes to the test, just realize that if they're asking you about overlapping channels, more than likely they're talking about 2.4 gigahertz. Okay. What is the big difference between 2.4 and 5.0? I just gave you one. One of them is the non overlapping channels. For 2.4, you're going to want to use 1, 6, and 11. In addition to the difference is the performance. Okay, greater range, better penetration. Okay, lower speeds. So if there's one thing you take away from this video, or at least this slide, and I gave you a lot of things to take away, is this: 2.4 is going to have greater range. That means it can travel a longer distance. It's going to have better penetration, which means if you have slabs of concrete walls layered upon each other and you want to put Wi-Fi in an underground bunker, you're more than likely going to use 2.4 because it's going to have better penetration through what would basically be the solids, like the walls. And however, the downside of that is the lower speeds. You're going to have lower speeds. Okay, let's go to 5.0. Notice we don't really talk about overlapping, non-overlapping channels on 5.0. Okay, just because of the sheer number of increased channels it generally has, right? 2.4 only had 11. 5.0 has anywhere between 36 to 165, just depending on the country and regulations. Okay, we don't really talk about overlapping channels when it comes to the 5.0 gigahertz. Interference and congestion, it's less prone. It's not perfect. It's just more, it's less likely to happen. And the performance, okay, this is something you should definitely know. Shorter range, lower penetration. However, it has higher speeds. Okay, it's a give and take here, guys. It's a give and take, right? 2.4, you had greater range, better penetration, but it was lower speeds. The 5.0 had shorter range, lower penetration, but higher speeds. Okay, so keep that in mind, 2.4 and the 5.0. And you guys can all see that here. If you can memorize this here, just knowing that the 2.4, lower speeds, longer range, 5 gigahertz, faster speed, shorter range, that would definitely help you. And you can start to go ahead and make up your own mind. Hey, this is my environment. I mean, I gave you guys an example, right? If you want to get Wi-Fi for an underground bunker that has layers and layers of concrete, hey, more than likely we're probably going to want to use a 2.4. Okay, if you are in an office setting and a lot of the applications that you need are demanding and they need they request higher speeds, hey, you know what, let's try to get that 5 gigahertz. Okay, so it just really depends on the situation, cost as well, your budget, so on and so forth. Bluetooth, a lot of this here is mumbo jumbo, so to speak. It really isn't, but it's perhaps more details than you would need. I think when it comes to Bluetooth, you should definitely know that, hey, Bluetooth, it's obviously its range is longer than NFC, but its range is shorter than Wi-Fi. Okay, this I found really interesting when I was actually looking into this. When I was looking at, hey, how exactly does Bluetooth work? So it actually sends small packets in different channels, and the channels, okay, and when it's sending that data through those channels, it has a predetermined pattern. So I found that really interesting. And whoever came up with it, maybe obviously they kind of knew what they were doing, but I just found that interesting that Bluetooth sends small packets through different channels in a particular pattern. And as you guys can see here, there's these standards here. If you want to go ahead and read and study upon those standards, go ahead. That is not my goal, so to speak. I just want to, when it comes to this section in general, the 2.3, like I said, I just need to know enough just so if they ask me questions on the Comptia A Plus, I can go ahead and pass, so to speak, which actually, funny enough, brings us to the 802.11 standards for Wi-Fi by the Institute of Electrical and Electronics Engineers. So this, guys, is something you definitely do want to study. And I'm going to be honest with you, when I first looked at this, I was like, no way. Like, am I supposed to memorize all this or what's going on? Um, here's the thing. Here's the thing. When the course objectives did ask us to compare and contrast different Wi-Fi standards, guys, but here is the thing. Okay, this is actually simpler than you think. 802.11 is the actual standard. They amend things, and as you can see, they had the A, they had the B, they had the G, they had the N, they had the AC, they had the AX. Out of all these years, 2024 is closer to 2019. So you can already deduce, hey, 802.11ax is the standard that we're most likely going to be dealing with. 802.11ax is the standard that we're most likely going to be dealing with when it comes to them, when it comes to us dealing with modern Wi-Fi standards. What is that standard? What are its details? Oh, look, it's 2.4 gigahertz and it's 5 gigahertz. Hey, we just talked about that. 2.4 gigahertz. It's going to have a longer range. It's going to have better penetration, but it has slower speeds. We just talked about 5 gigahertz. 5 gigahertz is going to have a shorter range. It's going to have less penetration, but it's going to have higher speeds. Okay. And it's looking, I think when I wrote the 9.6 gigabits per second, I was thinking about what it was, its maximum speed that it can output. In addition to, hey, OFDMA slash MIMO. So this right here is the technology that 802.11ax uses. And as you can see, MIMO actually comes up again in 802.11ac. Hey, MIMO came up again in 2009. hey, OFDMA, I mean, they were talking about that in 1999. OFDMA, now they're talking about OFDMA. Excuse me, they were talking about OFDM in 1999. Now they're talking about OFDMA in 2019. And it doesn't matter whether it's 802.11, ABGNACAX. For some reason, they keep using 2.4 gigahertz and 5 gigahertz. Okay, so you guys can see I just took you through my thought process of going ahead and being able to distinguish this, just knowing that, hey, we should probably read a little bit about OFDMA and MIMO, so on and so forth, and just knowing, hey, obviously, just think about it logically. In 1999, would they have had the same speeds and data, the same speeds that they have in 2019? Nah, you would think that the speeds would have gotten faster, right? And they have gotten faster. So just knowing that they keep amending things to the standard. What is the standard? The standard is 802.11. What standard are we on now for modern Wi-Fi? 802.11ax. Okay. So OFDMA. Okay, increases efficiency, reduces latency, ideal for low bandwidth applications. MIMO increases capacity, results in higher speeds per user, ideal for high bandwidth applications. Okay, and honestly, I know I didn't do enough justice, but I'll leave it up to you guys. You guys can go and study OFDMA or MIMO and try to tell me exactly how it works, what it means, so to speak. But we'll leave it there. So which brings us to word of the day. Okay, guys, when it comes to word of the day, today is technically two words: electromagnetic spectrum. Guys, if there's one thing that you take away from word of the day, and this was I was having some flashbacks to elementary physics. But if there's one thing that you take away from the day, this thing is that we are basically blind. We are blind because we don't see radio waves, we don't see microwaves, we don't see infrared waves, we don't see ultraviolet waves, we don't see X-rays, we don't see gamma rays. Literally, the only thing that we see here in this electromagnetic spectrum is the colors Roy G. Biv. That's red, orange, yellow, green, blue, indigo, violet. That is literally everything that we see is this small little slither here. Okay, this small little slither here. Everything else we're completely blind to. And the only reason why I bring this up, guys, is because when we're talking about Wi-Fi, we're talking about wireless technology and having the appreciation that there's literally wireless signals that look something like this, if our scientists are correct, that looks something like this traveling throughout literally in front of us, left of us, right of us, behind us, on top of us, below us. Like, it's pretty amazing. So I thought I'd just throw that in there. Um, I do have a great appreciation for physics and for their mission in trying to figure out how exactly the world works. And I mean, look where it's gotten us. We got some Wi-Fi now, so I'm pretty happy with that. Nonetheless, let's continue. So long range to fixed wireless. So basically, just know that the Federal Communications Commission is basically responsible for going ahead and regulating anytime someone's going ahead and putting out these signals, so to speak. If you want to go ahead and operate your own radio, you would technically need to be licensed. If you are uh, going ahead and setting up some Wi-Fi, you don't need a license. Open for public. What standard is that? 802.11. What standard are we currently on? It is the 802.11ax, which is from 2019. It uses the technology of OFDMA and it uses the technology of MIMO. In addition, it has the option for 2.4 gigahertz and 5.0 gigahertz. Okay, so just knowing that, hey, you can't just start operating a radio, so to speak, that you do have to go through the Federal Communication Commission. NFC, we talked about this here, not mumbo jumbo, so to speak, but just a little bit more details, like the frequency in which it's operating, 13.56 megahertz. Number of channels is one. You guys can look at these standards here, but just knowing that, hey, NFC is most likely working between 10 centimeters. Okay, that's something that is very, it has to be extremely close to its location. So I doubt that they might ask you this, but they might. So if they're saying um, NFC, the NFC communicator is not working and you're standing 5 feet apart, you would say, hey, no wonder it's not working. You're having a distance issue. You need to bring it closer together in order for NFC to work. Okay, so just being comparing Wi-Fi, Bluetooth, and NFC. Remember, it's the amount of data, the capacity of data it can transfer, in addition to its distance. Okay, and we talked about that on the previous presentations. Um, so RFID. Okay, this is Apple tags. Those little Apple tags are really good at this. That's basically, hey, trying to go ahead and if you tag something, being able to find it, so on and so forth. This technology is starting to come. I mean, it hasn't necessarily captured my attention, but I do know that they are speaking more and more about it, being able to tag things. You know, those people out there in the nature channel, they're like, hey, we went ahead and we tagged this tiger so we can follow and track its location, so on and so forth. They're using this technology right here. So RFID versus NFC, so you guys can have a quick little comparison. So on and so forth. And you can see, depending on the technology, right? Depending on your need, is is going to be the deciding factor on which technology you decide to use. Okay, and that basically does it for this particular slide. Like I said, there was a lot in here, guys. I honestly, I can't do enough justice with regards to actually looking at all of these, so to speak, because there is literally 1, 2, 3, 4, 5, 6, 7, and I mean, they literally did say compare and contrast. But I think if you just get the major key points, you'll be okay with this particular section. And that basically does it for us, guys. So that would go ahead and do it for us. Like I said, I would highly recommend you study this. Study this, and actually, let me go ahead and let's do this since we're here. Let me go to Google really quick, and let's just go. That way, you can say I didn't do it. OFDMA versus MIMO. Uh, AO2.11AX. All right, let's see. Let's see what's the first thing that comes up. Okay, OFDMA and MU-MIMO are, what is it? Are complementary technologies. While OFDMA is ideal for low bandwidth, small packet applications such as IoT sensors, MU-MIMO increases capacity and efficiency in high bandwidth applications like mission critical voice call and video streaming. Hmm. Yeah, so as you can see, I still need to dig in a little bit deeper. Hey, but at least I know one thing. OFDMA was more tailored towards what would be IoT, so things that are not necessarily as important, versus MIMO, where it's saying, "Hey, this is high critical information," such as voice calls. But like I said, I would highly recommend performance. Yeah, but right now I'm just trying to. I'm literally studying while I'm making a video. But maybe I don't know, guys. What do you guys think? You think we should go ahead? Hey, look at this though. 802.11ac versus 802.11ax. We already know that this is technically the standard, and the one that came before that was the 802.11ac. So see, watching some of the videos does help because it does put things into consideration. Uh, and we know that OFDM. Wow, we were talking about OFDM in what, 1999, and now we have OFDMA, which is more so in 2019. And you guys can start to look at this and start to see, hey, wow, it looks like they're starting to break things up, so to speak. So maybe I'll go ahead and about the author. Okay, cool. Um, she's a technical marketing engineer at Hewlett Packard. Nice. Okay. So let's go ahead and I'll add this article on there and on the video, so to speak, and then we can go ahead and start to look maybe a little bit more into this. But like I said, I wouldn't get too carried away with it. something that you would know, something that you would probably want to read when you're sitting in. Um, what does it call that? When you're sitting in the bathroom, so to speak. But other than that, guys, I'll see you guys on the next one.